Let's generalize. Calculation of the middle Riemann sum for f of x on the interval a to b using n subintervals. If you remember from the last video, our f of x was x squared, the interval ab was minus 2 to 3, and we used 5 subintervals. In this video, we want to look at how to construct the middle Riemann sum for an arbitrary function on an arbitrary interval using an arbitrary number of subintervals. So let's draw a picture of f of x. So again, just kind of scribble something up here. Let's say this is our interval. Here is A, here is B. This is the graph of f of x, obviously. Since we have n subintervals, what we're going to want to do is we're going to want to break this interval AB into n pieces or n subintervals. So we're going to break it into where the number of pieces, the number of subintervals is equal to n. Now, since the distance or the length of this interval, since the length of this interval is b minus a, we know that the length of each subinterval, which we denote as delta x, is simply b minus a over n. For this example, we're assuming that each of the subintervals has an equal length. Now, if we look at this, we know that this right here is x sub 1. This point right here is x sub 2, x sub 3, and so forth, all the way out to x sub n minus 1, x sub n, and the last value here, b, is going to be x sub n plus 1. So if I have n subintervals, then I'm going to have n plus 1 points that are going to create the partition of that interval AB. Okay. How do we get a general expression for x sub 1? Well, let's create a table. Or sorry, how do we get a general expression for x sub I? We create a table and just kind of look at some of them. So x sub 1 we know is a. Now x sub 2, we simply take x sub 1 plus delta x. That's going to give me a plus delta x. X sub 3 is x sub 2 plus delta x, which you can show as a plus 2 times delta x. In general, x sub j is x sub, is x sub, that's correct, is x sub j minus 1 plus delta x, which can be shown to be a plus Should be an I, not a J. So x sub I is x sub I minus 1 plus delta x, which can be shown to be A plus I minus 1 times delta x. So there is the general equation for x sub I. Now also remember that since this is a middle Riemann sum, that the x sub I star is going to be at the center of each of these subintervals. So again, this is x sub 1 star, and this is x sub 2 star, all the way out to the last interval, which will be x sub n star. Notice that when we're talking about the x sub I star, that there are going to be n of these because they're n subintervals. Let's see if we can generate a general expression for x sub I star. So x sub 1 is going to be, if you like, A plus 1/2 delta x, because it's in the center of that interval. X sub 2 is going to be x sub 1 plus delta x, which could be shown to be A plus 3/2 delta x. Okay. X sub 3 is x sub 2 plus delta x, which is A plus 5/2 delta x. And we can continue this. Sorry, these are stars again, sorry. Stars. And then x sub I star is x sub I minus 1 star plus delta x, which can be shown to be A plus 2i minus 1 times delta x over 2. Now finally, to calculate the middle Riemann sum, what we're going to do is, so the middle, let's put it over here since we run out of room, the middle Riemann sum is equal to the summation I equals 1 to n times f of x sub I star times delta x sub I. And for us, since this is the same for each subinterval I, we could write this as the summation I equals 1 to n f of x sub I star times delta x.